Hello students, today we will be going over 10.2, Solving Systems of Equations by Substitution. And our objective, I can solve a system of equations by substitution. And we have our two different equations here. And you say which one has an isolated variable. This y equals is by itself, but this has x and y together. So what you need to do is take this 5x plus 7 and substitute it for the y, which is what they do here. See, they have negative 2x right there, and then they have plus 3, and then they substituted 5x plus 7 in for that. Y equals negative 5. And then they were able to go down and solve for x, substitute it back in, and then you can get your y. And there's your solution, negative 2 comma negative 3. So here's our steps for substitution. I'm going to go ahead and do problem number 1, going through these steps for substitution. Number 1, identify the isolated variable. Which variable is by itself? Well, this has x and y. This one just has y. So I'm going to substitute this 6 in for the y here, and then I'll solve for x. So if I put 6 in, substitute it there, I get 6 equals negative 7x minus 22. Okay, then I'm going to add 22 to this side, add 22 to this side, and I just go through my normal steps to solve for x. Okay, now x is negative 4. Usually you have to plug it back into one of the equations, but we know y is already 6. So our solution will be negative 4, comma 6. And you want your solution in ordered pair form, if it happens to be an ordered pair. Okay, now we're going to go on to number 2. We say which one is isolated? X, only x in there. So I'm going to put a 1 in for x there. So I put negative 1 minus 3y equals negative 19. And I solve for y. Add 1. Make sure you bring this down. Okay, divide by negative 3. Y equals 6. Now, be very careful when you're solving for y not to put it as your x value. Now we put our ordered pair. X is 1 and y is 6. Okay? And we're done with number 2. Okay, let's go on to the next page. Go to number 8. That's a little bit more challenging. Okay, so here we don't have anything all by itself, but we do have this one solved for y. So what I'm going to do is I'm going to take this whole thing and I'm going to put it in for that y right there. So I write this first equation exactly like it is, substituting this whole thing for y. So I put 7x minus 6. Now 6 has to be multiplied by both of these, because it's minus 6 times y. Okay. Okay, I have to make sure I use the distributive property, and I say 7x plus negative 42x plus 56 equals negative 16. Now 7x plus negative 42x, I think, is negative 36x. Then I'm going to subtract 56 here. Subtract 56. Negative 36x equals, is that negative 72 divided by negative 36? and x equals 2. Okay, now we don't know what y is until we plug it back in. So we're going to plug it back into one of the equations, okay? I'm going to go ahead and say y equals 7 times x minus 9. We know x is 2. So y equals 14 minus 9. So I know y equals 5. So my ordered pair is my x is first, 2, and my y is second, 5. And we're done. Okay, now 10 looks a little bit suspicious here with both of them solved for x. What do you do now? Well, we just decide to take one of them here and we substitute it for that x down there. So I take this whole thing, 5y minus 3 equals y plus 5. Okay, now we can draw a line down the equal sign. We're going to get the y's all on the same side. 4y minus 3 equals 5. Get the constants on the other side. Oops, my mind jumped ahead. It was saying 2. Okay. Now, if our y is 2, we need to figure out what our x is. So we can put that in there, 2 plus 5, and we know our x is 7. So we put our ordered pair, our x and our y. Okay. All right, students, you can get the rest of this. You rock.